The discussion this week concerns how to choose the right statistical test when you have a problem that you are dealing with. So, as we can see up here, we start from the beginning, and there are several categories of data that we have to deal with. If we go to this diamond shaped box here, it says, are you looking at categories as your data? In the middle here, the question is, are you looking at differences in your data? Or in the right diamond shaped box, it's asking whether you are looking at correlations. So there are three categories of data that we can look at: categories, differences, and correlations. So depending on whether you are determining the categories in which your data may fall, you will have to choose the chi-square test to determine the categories in which your data fall. If you are looking at correlations between variables, which we will come to later on, this is where you go to the parametric statistics, and under the parametric statistics, the one we will be looking at is the Pearson's correlation coefficient. That's the Pearson's R. Now you may see in some of the boxes I have blacked out what is in there. It is done to enable you only to focus on the items we will be considering in this course. There are several different strategies for analyzing data, but we will not have time within this semester to consider all the possible data analysis strategies that we can use. So I have blocked them out. Don't worry about that. If you go on to do doctoral degree or any graduate degree, you may need to know some of these other things. But for this purpose, we are only considering those items that have not been blocked out. So to come back, if you're looking at categories, you are considering chi-square as the test. If you're looking at correlations, you are considering Pearson, which is a part of the parametric statistics. It is shortened for para, but the full name is parametric statistics. But most of the time we will spend on considering differences between the data that we have got. Now, if you are considering differences, the next question that you have to ask yourself is this box here. Are you considering differences when you have one independent variable or two or more independent variables? The answer to that question will determine the eventual statistical test that you will need to use. So if we are considering an experiment in which there is one independent variable, then we have to go to the left here because that is where the one independent variable is pointing as 2. So if our answer, and for most of the things that we will be doing, we will be considering one independent variable. So you will always have to go to the left here. The next question that comes up is, how many conditions are there? How many experimental conditions are there in your design that you are considering? You could have 2, and 2 is the minimum number of conditions that you need to have an experiment. But you could also have 3 or more. Depending on what your conditions are, you will have to go either to the left or the right. If you are considering conditions, those are the situations under which the participants in the experiment are being exposed to something. So if we consider an experiment in which the researcher is interested in, say, the effect of temperature on students' ability to do statistical tests. So you can create two conditions. One condition is a cool room. Maybe the temperature there is about 70 degrees. And another room in which the temperature is quite hot. So the temperature may be 90 degrees. So you are comparing two conditions, the cool room of 70 degrees versus the hot room of 90 degrees. In this kind of experiment, you'll be considering two experimental conditions, the cool room and the hot room. The next question that comes up is, do you have the same or different subjects in each condition of this experiment that you are considering? The answer to that question could determine what kind of statistical test you use to determine the differences in the performance under the conditions of the experiment. If you have the same individuals being exposed to the cool room and the hot room, then you have the same subjects in the conditions of the experiment, in which sense your test that you will need to use for determining differences between the performance in the two different conditions is the t-test for related samples. This is the eventual test we are considering here. And it is a test that comes under the parametric statistics. So it is the t-test for related samples. That is when you have the same subjects in the conditions of the experiment. If on the other hand you have different subjects in the conditions of the experiment, in which case the participants in the cool room are different from those in the hot room, then you have to use the t-test for unrelated samples. It is also a test under the parametric test. That's why, as you can see, all the tests that we are considering are parametric tests. So if the individuals in the conditions are different, you use the t-test for unrelated samples. It is important to include unrelated. Whereas if it is the same group of individuals being exposed to the two conditions of the experiment, your test will have to be the t-test for related samples. To continue, if we are considering an experiment in which there are 3 or more conditions, in which case we have a very cold room, which may be 45 degrees, a cool room, which is 70 degrees, and a hot room, which is 90 degrees. Now we have no more 2 conditions, but we have 3. A cold room, a cool room, and a hot room. Again, if we answer that question that we have 3 or more, then the next question will be, do you have the same or different subjects in each condition of this experiment? If the individuals that are exposed to the cold room, the 45 degrees, are the same individuals that are exposed to the cool room, the 70 degrees, and the same individuals that are exposed to the hot room, the 90 degrees, then you have to answer that you have the same individuals in this experiment. In which case, the test that you will have to use under the parametric test is the one-way ANOVA. ANOVA stands for analysis of variance for related samples. So the test, if you have 3 or more conditions and it's the same individuals, the test that you use for determining differences in the performance under the 3 different conditions is the one-way ANOVA for related samples. If, on the other hand, you have different individuals being exposed to the cold room, the cool room, and the hot room, then you have to say you have different individuals, and for that, the test you use for determining differences in the performance under these three different conditions, the cold, the cool, and the hot, is the one-way ANOVA for unrelated samples. Hopefully this is clear, but if it is not, please send me an email and I will try to explain it one more time. To summarize, we are looking at three possibilities in terms of how we analyze data. If we are interested in looking at the categories in which our data fall, then we have to consider a chi-square. If we are looking at the correlation, the relationships between variables, say variable A and variable B, then you have to consider correlations. But for most parts, we will be looking at differences in the performance under some conditions that individuals have been exposed to. There could be the same individuals being exposed to the conditions or different individuals being exposed to the conditions. If we are considering an experiment in which there is one independent variable, and the independent variable is the variable that the researcher is systematically manipulating in order to see its effect on some performance. So, for example, the temperature experiment, the independent variable will be the temperature. Under the temperature, we know it is one thing, that's the temperature. Under the temperature, the researcher has created two conditions. So if we come to how many conditions, there are two. So if there are two, the next question will have to be, do you have the same individuals being exposed to the conditions of the experiment, or you have two different groups of individuals? If it is the same individuals, then your test that you use to determine differences in their performance is the t-test for related samples. If it is different individuals, it is the t-test for unrelated samples. If you have three or more conditions under the independent variable, that is the one independent variable, in this case the temperature, then you have to go to the right. And then the same question comes up. Do you have the same individuals being exposed to the three conditions of the experiment, or do you have different individuals being exposed to the three conditions of the experiment? The answer to this question will determine what statistical test you use to determine differences in their performance. If it is the same individuals, the test we use is the one-way analysis of variance. Analysis of variance shortened is ANOVA for related samples. If it is different groups of individuals in the three different conditions, then the test you use is the one-way ANOVA for unrelated samples. Hopefully this is clear. Let us now consider some questions that will require us to determine what kind of statistical test we use for the analysis. So you can read this question yourself. It says a researcher conducted an experiment to test the ability of students to remember information from a complex text as compared to a simple text. One group of students was randomly selected for the condition where they were given information in a simple text to read, whereas the second group was put in the condition where they read information in a complex text. The information they were required to memorize was the same, although it was the text that was either simple or complex. The questions we have to answer are the following. A. what is or are the independent variable or variables in this experiment. So let us go back to the chart and try to see how we can analyze this. If we go to the chart, it says there are two groups of individuals and they had to read a text. One group read a simple text and the other read a complex text. So if we go back to the question that we were given to consider, the question says, what is or are the independent variable or variables in this experiment? And really, actually, this is tautological. So let's take out this. So if we have to consider the independent variable or variables in this experiment, the question is it one or is it two? We know it's the text, and we are looking at how complex the text is. So the independent variable is text complexity. It is the complexity of the text that is being manipulated by this experimenter. Why is it the text complexity? Because if we consider it again, it is either a complex text or a simple text. So you are looking at the complexity of the text as the independent variable. So we have one independent variable. What is or are the dependent variable or variables? The dependent variable, that is what the researcher is interested in collecting as the data, is the amount of information memorized or the amount of information recalled by these individuals who were exposed to the text. So the answer to A is one independent variable. The answer to B is the amount of information memorized. That's the dependent variable. The third question is, how many conditions are there in the experiment? This is simple. He created two conditions. One condition was the complex text. The other condition was the simple text. So you have two experimental conditions in this experiment. The last question is, what statistical test must be used for analysis? What test must the researcher use for analysis? And in this case, if we go back to the chart and we consider what has happened, we are looking for differences. There is one independent variable. There are two conditions, that is the simple and the complex. And the question is, do you have the same or different subjects in each condition of the experiment? If we go back to the question, we can see that the answer is one group of students was randomly selected for the condition where they were giving information in a simple text to read. So one group was giving a simple text to read. The second group was giving the complex text to read. So there are two different groups in this experiment. You are either in the simple text group or in the complex text group. So two separate groups of individuals are being exposed to the information here. In that sense, we are looking at different groups of individuals, and the statistical test that has to be used to compare the differences between these groups is the t-test for unrelated samples. So your answer for question D, what statistical test must the researcher use for analysis, is the t-test for unrelated samples or groups. The second question is this. 3 groups of 20 subjects each were given a list of words to learn. The words were presented at the rate of 5 seconds per word to the first group, 2 seconds per word to the second group, and 1 second per word to the last group. The researcher had predicted that the recall will be affected by the rate of presentation. So again, we have three groups of individuals. One group was giving the words at 5 seconds per word. The second was 2 seconds per word, and the last group 1 second per word. They were all required to memorize so they can be asked to recall as many of the words that were exposed to them. What is or are the independent variables? In this experiment, what is being manipulated by this researcher is the rate of presentation. So the independent variable is the rate of presentation because you have either 5 seconds, 2 seconds, or 1 second. So the independent variable is the rate at which the words were being presented to the participants in this experiment. The second question is, what is or are the dependent variable or variables? What is or are the dependent variable or variables? And the answer to this question is very simple. The researcher is interested in the recall. So the recall or the memory for the words presented to the participants is the dependent variable. The third question is, how many conditions are there in the experiment? And it is very easy to see. You are either presented with 5 seconds per word to the first group, 2 seconds per word to the second group, and 1 second per word to the last group. So in this experiment, you have 3 conditions. So the answer to question C is 3 conditions. The next question is, what statistical test must the researcher use for analysis? Again, if we go back to our chart here, we know we have one independent variable, which is the rate of presentation of the words. How many conditions? We know we have 3 because you are either 5 seconds, 2 seconds, or 1 second. The last question is, do you have the same individuals being exposed to the 5, 2, and 1, or different groups of individuals? And we know they are different groups. One in the 5 second group, the other group is the 2 seconds group, and the third group is the 1 second group. So the test for determining differences in the record that these participants gave at the end of the experiment is the one-way ANOVA for unrelated groups or samples. That is the answer to question D for the second problem. The third question is, 20 students were all tested on their basic algebra skills under conditions in which they solved problems in a room in which there was a lot of ambient noise, in another room in which there was no ambient noise. The researcher was interested in how many of the questions the students solved correctly. So, for this question, we are looking at 20 students. They were all tested on their algebra skills under conditions in which they solved the problems in a room in which there was a lot of ambient noise and another in which there was no ambient noise. So the independent variable that is being manipulated here is the noise in the room in which the problem was solved. You were either in a loud room where there was a lot of ambient noise, or in a quiet room in which there was no ambient noise. So The noise level is what is being manipulated. So that is the answer to what is or are the independent variables. The next question is, what is or are the dependent variables? The dependent variable is what the researcher is interested in. It says the researcher was interested in how many of the questions the students solved correctly. So the dependent variable is the number of questions solved in this experiment. The third question is, how many conditions are there in the experiment? How many conditions? Here we are considering the conditions created by the experimenter. And if we go back to the initial statements, he created two conditions. One in which there was a lot of ambient noise and another in which there was no ambient noise. So there are two conditions in this experiment. How many conditions? The answer to C is 2. The last question is, what statistical test must the researcher use for analysis? Again, let's go quickly to the chart that we have been using. So here we are looking for differences. We have one independent variable. We have two conditions. And the question is, are there the same or different subjects in each condition? And for this problem, all the 20 individuals were first exposed to the room in which there was a lot of noise, and then the room in which there was no ambient noise. So we have the same individuals being exposed to the two different conditions. So the test to be used is the t-test for related samples. That is the test to be used. Let's go now to the last question. The last question says, a group of 30 students was tested for their memory following exposure to words that were short and long. A group, again, it tells you a group, that is, we are talking of one group of 30 students. It's the same as 20 students were all tested. So that is a dead giveaway as to what we are looking at. The question is, what is or are the independent variable or variables in this experiment? And if we consider this, the students were exposed to words that were short and long. So the length of the words is the independent variable. The length of words is the independent variable. What is the dependent variable? Is their memory, or the number of words that they record at the end of this experiment. How many conditions are there in the experiment? Here the answer is simple. You were either giving a short or a long word. So there are two conditions in this experiment. What statistical test must the researcher use for analysis? Let's go back quickly to the chart and see what happens. Here we are considering one independent variable, which is the length of the words. How many experimental conditions? We know we have two, short and long. And the next question is, do you have the same or different individuals being exposed to the short and the long words? Is the same individuals? So if we go back, it says a group of 30 students was tested for their memory following exposure to words that were short and long. It's the same group of individuals who were given the short words and the long words. So for this experiment, what we are looking at, if we go back briefly to the chart, is we have the same group of individuals. There are two groups. There's the same group of individuals. There are two conditions, I should say. And because of that, the test that has to be used is the t-test for related samples. Again, we have one independent variable, two conditions, being exposed to short words or long words, then it's the same individuals who are exposed to the short words and the long words. And because of that, the test that has to be used for determining differences in the number of words that were memorized under the two separate conditions of short and long words is the t-test for related samples.